Hey, ladies and gentlemen, this is Miss Humbert. Welcome to our very first note video for concepts for trimester 3. So first thing I want to do is just do a little bit of what we did yesterday with reviewing probability. So let's say we have a number cube. Now we all know there's 6 numbers on a number cube. That means that we have 6 total successes. Remember that, or sorry, 6 total numbers. Remember that probability is success is on the bottom, or on the top. The number of successes we have is on the top, and the total number of options we have is on the bottom. Success over our total number of options. So let's find the probability of getting a 2. Well, there's only 1 2 on the dice, so the probability is just 1 over 6. Now, the best way to do that is to leave that as a reduced fraction, but if you want to write the decimal, you can do that as well. Let's take a look at number 2, the probability of getting an even on the dice. Well, on the dice we have an even 2, a 4, and a 6. So we have 2, 4, and 6. Those are our even numbers on the dice. Okay, so if you notice, that's 3 total numbers. So 3 out of our 6 total numbers is our probability. Now we're going to reduce that fraction to 1/2. And again, if you wanted to, you could write that as a decimal. I want you guys to pause the video right now and on your own, see if you can figure out the probability of getting a prime number. Here are the prime numbers that are on a dice. Remember, 2 is a prime number. It is the only even number that is prime. A prime number is a number that can only be divided by 1 in itself, and that's true of 2. Okay, so the prime numbers on dice are 2, 3, and 5. See if you can calculate the probability of getting a prime number. Let's take a look if we have 2 things happening at once. Okay, we're rolling 2 dice at the same time, and I want to find the probability of getting 2 4s. Now I'm going to do that by multiplying those 2 probabilities. So the probability of getting a 4 on the first die, well, there's 1 4 out of 6 total. Same for the second die. Okay, so there's 1 4 out of 6 total on both dice. So then I'm going to take and I'm going to multiply those 2 numbers together. Okay, so when you multiply fractions, you multiply across the numerator and across the denominator. So I'm going to take 1 times 1, which is 1, 6 times 6, which is 36. So my probability is 1 over 36. Again, you can write that as a decimal if you'd like. All right, so let's take a look at part B. Again, we're multiplying those probabilities. So first, let's just look at the probability of getting a 2. So the probability of getting a 2, well, there's 1 success over 6 total. Then the probability of getting a 3, well, there's 1 success out of 6 total. Then you're going to multiply those 2 together. Go ahead and finish it up on your own. It should be pretty simple if you look at the previous problem. Let's take a look at part C. Okay, so I want to find the probability that I get 1, and then I can get any number I want. Okay, so first of all, let's look at this first and foremost. So the probability that I get 1. Okay, so that's 1 success over 6 total. There's 1 1 on the dice, 6 total on the dice, 1 over 6. Now, then the probability that I get any number. So I could get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, well, that means that I have 6 successes over 6 total. Okay, then when I multiply across the top, 1 times 6 is 6. Then multiply across the bottom, 6 times 6 is 36. Last but not least, I really suggest you reduce that fraction. 6 over 36 is going to reduce to 1/6. Okay, and that's your probability. Now let's take a look at how we're going to be using this. So I'm going to talk way faster than you can write this down. So what I want you to do is pause the video, take the time to write what you need to, okay? You can take as much time as you need. So first of all, we've talked about probability a little bit, that it's the number of successful outcomes over the total possible outcomes. That's not new. That's stuff we did even last trimester. Okay, so when we have that P of, like you saw in the previous problems, that means the probability of rolling a 4. Okay, so we have our success over our possibilities. Again, that first part shouldn't be that new to you. The new stuff comes with this independent events. Okay, so that means that we have 2 events going on, and the result of one does not impact the result of the other. Okay, so if we're rolling 2 separate die, what I get on one die isn't going to affect the other dice. All right, so another example you're going to see a lot is when you're drawing out of a deck of cards. If I draw a card of the deck of cards, but then I put it back, that putting it back keeps my total the same. And if I draw again, I still have just as equally likely of chance of drawing that card again. Okay, so they don't affect each other. So that's what we're going to be looking at today, are those independent events when they do not affect each other. So here's the biggest thing, and that's going to come into play more next week. Now, if you look, there's a little note just below your chart. Remember that and means you need to multiply. So I want to make sure you write down multiply. And means you need to multiply. Okay? All right, let's take a look at some of these word problems. At a picnic, Julio reaches an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes the can, then decides he is not really thirsty and puts it back. What is the probability that Julio and the next person to reach in the cooler both randomly select a regular soft drink? So first thing I want to do is figure out my number of successes. Okay, so I see that I have 8 regular soft drinks and 5 diet soft drinks. So I add those two together and I have 13 total soft drinks. So I have 13 drinks in the bin. Okay, now I want to find the probability that both of them get a regular drink. The fact that Julio puts the can back in after he's done is what makes it an independent event. We still have the same total. So when Julio first reaches in, there's 8 total soft drinks out of the 13. Regular soft drinks out of the 18. Next, okay, he's going to put that back in. Our total doesn't change. Okay, so he puts that soda can back in, and then we still have 13 total because he put it back in. So we still have 13 total because he put it back in, and we still have 8 regular soft drinks because he put it back in. So now we're going to go through and multiply out this fraction. Again, with fractions, you're going to multiply the top first. 8 times 8 is 64. Then you're going to multiply the bottom. 13 times 13 is 169. You can leave it as a fraction like that, or you could put it as a decimal. If you put it as a decimal, it's 0.379. So about 38% chance that we're going to have that exact scenario happen. Okay, if you didn't understand that, go ahead and rewind the video a little bit. Watch it again. See if that helps. Let's take a look at number 4. A cage contains 3 white and 6 brown hamsters. Maggie randomly selects one, puts it back, then randomly selects the other. What is the probability that both selections were white? Okay, so let's first figure out how many hamsters we have. So we have 3 white and 6 brown. So we have 9 total hamsters. So that's going to be our total on the bottom. Okay, the question asks us, what is the probability that both selections were white? Well, how many white do we have? Well, first we have this, there's 3 white. Now when it says both, that's applying 2 events happening. And it tells us that once the hamster is taken out, it's put back in. Okay, once the hamster is taken out, it's put back in. So the first time I draw out a hamster, there's a 3 out of 9 chance that I draw a white one. I'm going to put that white one back in. And then because it's back in, my total is still 9. And I have 3 white hamsters still. So now we're going to go ahead and we're going to multiply across. So we have 3 times 3, which is 9. 9 times 9, which is 81. You want to go ahead and reduce that fraction if you're going to leave it as a fraction. This is the same as 0.11. So there's an 11% chance of drawing both white hamsters. Okay, moving forward. Let's take a look at this one about Mr. Peshman. I'm going to get it set up for you, and then I want you guys to go ahead and take it from here. First of all, I want you to change this to say 16 boys. Okay, so that should say 16 boys. So go ahead and change that for me. All right, so first I have to figure out how many total students we have. Well, there's 14 girls, and there's 16 boys. So we have 30 total students. Okay, so for 30 total students, the question is asking us, hey, again, I'm not going to always read through the problem, so if you need to pause the video, take a little read through for yourself, that's fine. Okay, so we have 14 girls and 16 boys, and we want to find the probability that he's going to pick a girl and then a boy. So first thing I want to do is figure out the probability that he picks a girl. Well, that probability is going to be 14 out of 30. Probability that he picks a girl. Then I want to figure out the probability that after that he picks a boy. Well, let's say one of our students comes up to the front of the board. Okay, they sit back down, and Mr. Peshman is not very fair. He's just as likely to pick that person again. So if someone, we'll call her Shirley, comes up to the board, Shirley sits back down, Mr. Peshman could very well call on Shirley again. So there's still 30 students for Mr. Peshman to choose from. Okay, however, we want the second one to be a boy, and that number of success is 16. Okay, so really you're looking at each event, figuring out what's the probability of this, what's the probability of this, and then you're multiplying the two together. So I want you to go ahead, finish this problem up for me. Take 14 times 16, take 30 times 30. Okay, I want you guys to do those on your own. You're going to be showing me your completed note sheet here at the end. So make sure you actually do that because I will require a completed note sheet in order to get your homework. All right, next, let's take a look at number 6 and number 7. We're dealing with some cards. Okay, so what is the probability that you draw a jack from a deck of cards, replace it, and draw a 7? So think in a deck of cards. There's 4 jacks in a deck of cards. Okay, there's a jack of spades, jack of clubs, jack of hearts, jack of diamonds. So there's 4, and there's 52 total cards. So there's 4 out of 52 is our probability here. Okay, so we're going to reach in that card, and we're going to pull out our jack. We nailed it. We got it. Okay, we got the jack. Now I'm going to put that jack back into the deck. When I put that card back in, that means that my total is still 52. And now I want to calculate the probability of getting a 7. So I have the 7 of clubs, 7 of diamonds, 7 of spades, 7 of hearts. So there's 4 sevens. Okay, so really the probability of drawing any given card is 4 out of 52, okay, or any given number. So let's go ahead. First thing we're going to do is multiply those numerators on top. 4 times 4 is 16. 52 times 52 is going to give you 2,704. You can reduce that fraction to be 169, and then you get 0.006. Taking a look at number 7, what is the probability that you draw a spade and put it back in and draw a face card? Okay, well, the probability of drawing a spade, that's one of our suits. There's 4 suits in a deck. Okay, there's 52 cards, which means we take 52 divided by 4. That's going to give us 13 spades in a deck. Okay, there's 13 spades, 13 hearts, 13 diamonds, 13 clubs. And that's out of 52 total cards. Then I want to figure out how many face cards I have. Well, there's Jack, Queen, King, Queen. There's 3 face cards per each suit times 4 suits. So that gives us 12 out of 52. Write that fraction out. You get 156 over 3,000. Oops, this should be over 52. So this should be divided by 2,704. And I'm going to leave it up to you to simplify that fraction for me and get the decimal. So just quick calculate that on your own. Let's take a look. I'm going to have you do number 8 entirely on your own. So again, I'm not going to accept blank answers, so please make sure you actually do it because I'm going to make you show me the completed note sheet in order to get your homework to move forward in the class. Let's take a look at this one. This one's a little bit tricky. Miss Johnson is picking out a new pair of socks at Target. There are 6 different designs. What is the probability that she pulls out a zebra design, put it back, and pulls out a leopard design? Well, first thing we know, there's 6 total designs. Okay, there's 6 total designs. Only one of them is a zebra design. So the probability that she's going to pull out a zebra design initially is 1 out of 6. Now, we see that's a 0 sock, and we say, ooh, we don't want that. So we put it back into the bin. Next, I'm going to reach in the bin and I want to pull out a leopard sock. Well, leopard sock is only 1 out of the 6 designs. So again, I have 1 out of 6. So the next thing I'm going to do is I'm going to multiply these 2 probabilities together. That's how I can find the probability of this exact situation happening. So 1 times 1 is just 1. 6 times 6 is 36. So that's a completely reduced fraction, so you can leave it that way, or you can write it as 0.028. Either way works. So this concludes your video. Make sure you have all of the work filled out. Then I'm going to have you bring your worksheet up to Miss Humbert. I'm going to check it over, and then I will hand you your homework sheet. Thanks for listening.